We talked about the problems with the non-object query languages, and we mentioned some problems. Now it's time to move on and explain more about object-oriented languages. So just a few reminding and reviews from the last class. So you remember we had this example where we divided a unnormalized tree to unnormalized date table to 3 tables, and then for example here we have a table for personal social security number and name, and then we have a table for phone numbers and social security numbers, which is a 1 to, this is a table personal, this is a table phone. There is a one-to-many relationship between this table to this table. For each person may have several phone numbers. Also, you have a self relationship over here. There is a one-to-many relationship from this social security number to this social security number. This is a foreign key pointing to this key, and so this is also foreign key pointing to this key. This is a self relationship and shows that who is the child of whom. Okay. And then we realize that if we want to, for example, find the phone numbers of grandchildren of, for example, a person, it will be difficult because why? Because first of all, we have to multiply table personal, multiply table child of twice to itself to find the first time to find the children, the second time to find the grandchildren. Then join it to the table of phone to join it to the table of phone to find phone numbers. Okay. Yeah, you can see that you are multiplying. Sorry, table person twice. 3 times person P, person C, person G. These are joint conditions, and then we put this constraint over here, and then finally we get phone numbers of the G. So, sorry, this is the original relationship, and this is the normalized relationship. So what if we want to write a query for database or object-oriented database? Suppose that we have objects and we have relationship including sets and list of objects. What happens if we have a database like this? Is it easier or not? Suppose that in this database, if you want to think object-oriented, the first solution coming to your mind is creating 2 objects. How many people do we have here? 2. Joe and Bob, okay? And also, we see that Bob is child of Joe, and also Bob has some children also over there. We cannot see, we don't see those children here. So if you want to make it object-oriented, what we are doing is we are assuming for each person one object. So each person is identified by its social security number. So how many people do we have in this database? 2. One is Joe, public, the other one is Bob. And since we can have sets over here, phone numbers can be sets, and also child number of child, it can be sets of references to another objects. Then we can have sets over here. So we have sets of attributes here. So if we have such a schema in object-oriented database, or instead of database, think about Java, some languages like Java. So what happens is, if you want to write a query, if we manipulate or change this SQL language, the only thing to recognize the grandchildren of a person is, the only requirement is name of the object. If you know that the person is P, and we know that the child of the person is P, that child, and the this P dot child is also a person, right? Because we had this set of person referencing to. If I put the child, the dot child over here, it means that a child of this child, it means that grandchildren of that person. Also, this child also has this phone number. If I select it through a dot phone, a phone, and then I am selecting phone numbers of grandchildren of P. Okay, if P is now Joe public, now if in the name of the P we put this constraint Joe public, then we are finding the phone numbers of grandchildren of Joe public. Okay. So here, what you see here in the select part, you see a path on the graph. So if you assume that every when you have a child over here, when you have some reference over here, the hierarchy of the objects, the extent of the objects are a tree, then on this tree, what you are doing is, on some specific attribute, you are writing a path from the person to one of these childs, from that child to its child. So this is a path, right? It's a general path. It can apply to many people. So if I define a single node, Joe public's node, then this path is pointing to his grandchildren's, and his grandchildren's also have another part, which is phone number. So the point is that in the object-oriented databases, we need to, when you are writing a select query, you need to specify a path from one object to the attributes that you are interested in. Another advantage of object-oriented databases. So in object-oriented, the main advantage is getting benefits from inheritance, right? Inheritance is giving you a higher level of abstraction, okay? So if we use the same concept here in the databases, what happens? We still get benefits, right? You still get benefits of having this abstraction. Suppose that you have two tables. You have a table of person, you have a table of a student, okay? A person, table of person is defining the name of the person, and the table of the student has a one-to-many relationship. Sorry, the table of person has one-to-many relationship to the table of a student, okay? And for each student, you can have several majors, okay? Suppose that Bennett can have two majors, mathematics and computer science. So Bennett will have one record to the table of person. He will have two records in the table of student with his social security number. So if I want to find all of the, for example, I want to find all of the students in computer science department, what I need to do is basically I need to do the join between person and student on the constraint of having same social security numbers, and also put the constraint, put this condition, and look for computer science students. If we solve this problem from object-oriented point of view, each student is a person, right? So if you just specify this relationship, saying that, okay, each student is a person, so then consider students as an object, who are person, who has name, and who may have several majors, okay? So then, how do you write the schema for the students? How do you write the schema for this? The better to write over here, because it's not standing as students. Let's try. So then a student is a person with social security number, which is integer, and name is a string, and also major. What is the major?
String.
No, it's a set of strings, right? So that it could be, it's possible that one person have several majors, right? So in this case, then if you want to look for computer science students, the only thing you need to do is, when you want to extract the name, you need to specify this path here, the name of the student. This is which attribute, this is the attribute you are interested in, from sets of students, from the objects of students. If the object S is a student, then we put this constraint that the major of the S has to have CS in it. Okay, so you can see that obviously the query gets much simpler. No join over here, right? So these are benefits that you can get from the. Okay, so more stuff in object-oriented. You have functions associated with classes, right? Each class may have several functions or methods. Okay, so if you decide and define on some specific class a particular function or method, then that function can be applied on the objects as well, on the objects of that method. For example, suppose that you have a database of movies. Okay, a movie, regardless of how we store this, a movie is a file of a string, a file of frames. Okay, if you define a function frame range from some specific frame to another specific frame, then what happens is when you call this query, basically movies of Simpsons, the Simpsons will be retrieved. Then that function will be applied to that, and the set of frames will be returned to you. This is a function, not a specific attribute. So now we get one more benefit, which is much more general than what we had over here, which is applying functions on a specific type of data. Now, the problem, the impedance mismatch. What is the impedance mismatch? We talked about object-oriented, and we thought that object-oriented is good, okay? But now, for the databases, we have SQL, right? So if we change SQL to object-oriented SQL, can we still write applications in SQL? No, because it's much limited, and it's a high-level abstract language to write just query, to write data retrieve and information retrieval and data manipulations. There are some differences, there are some problems or natural problems inside of natural differences between object-oriented languages and database languages that we have to resolve in order to get benefits of object orientation in the databases. Okay, the first difference, or the first problem or issue with the SQL, traditional SQL, is that SQL is a set-oriented language, right? Everything is relations. Everything is set of tuples. So, and the only thing you have over there is operations on those tuples. So you don't have any object, okay? But in the host languages, in object-oriented host languages, okay, where you want to get benefits of object orientation, as we mentioned here, we had several benefits of object orientation from data point of view. In the host languages, you are facing with records. If the database is, if the language is object oriented, you don't have relations. The units of information is records, not sets. The other problem, or the other mismatch. SQL is declarative language, right? In the SQL, you don't say to database how to retrieve some information. The only thing you say is select something from somewhere and give me that. You don't care about how it does. We learned about how it does from database tuning point of view, not from the programmer point of view. But in the host languages, all of them are procedural. There are imperative languages. You have to tell to computer what kind of steps it has to take to do some operations. Okay, so the nature of these two languages are different. So this is called this difference between SQL and the host languages, object-oriented host languages. We want to use the SQL as a data language. It's called impedance mismatch. Okay, can we bridge the gap? Can we solve the problem? Okay, the whole idea behind the object-oriented databases is bridging this gap. Okay, we have this data language, which we knew that is what we learned from beginning to here was all of them was SQL and set-based, and we have this host languages, we have these languages, they need some object-oriented point of view because of those benefits we showed, and they know that object-oriented languages are simpler for the developer. Now, we want to leverage SQL to support object orientation. So this is the idea. This is what we are looking for in this for the rest of our classes until the end of the semester. Okay, so if you want to bridge the gap, what are the problems? What are the issues? Similar to what we mentioned over here, differences. Again, object-oriented languages are procedural. The main advantage of SQL, it was an advantage of SQL that you don't bother yourself to tell to database how to retrieve the information. You don't say anything about loops or hash join or anything like that. You just say select, and this is the database task. So the first problem is that you want to keep the benefits of declarative language. You don't want to sacrifice that benefit. So when you want to bridge this gap, you have to resolve this issue. You have to keep the benefits of a declarative language. The other problem, there are tons of object-oriented language out there, and you cannot say that, okay, instead of SQL from now on, use, for example, C++ or Smalltalk or object-oriented Pascal or Java. Why? Because they are all different. There is no one standard for object orientation. But SQL was a standard and was single, right? So the whole benefit of SQL was that the SQL query you write in MySQL with a very, very small changes can be executed in Oracle and SQL Server and PostgreSQL and other DBMSs. But here you have tons of variations, so you have to decide which one you want to select and use as an object-oriented language. Or your object-oriented SQL should be merged and should be linked to which one. Okay, which one is the best one? Okay, so now there are two directions for this problem, to solve this problem, two main approaches. The first one is ODMG, Object Database Management Group. This group is trying to define a standard database data language, which is object-oriented. And another group is trying to change SQL. They try to add something to the SQL, not rebuilding from the scratch to support objects. There are two different approaches. Okay, in order to bridge the gap, first we need to just highlight the differences between object-oriented, object databases and relational databases. What we are looking for, what we have. In the relational databases, we have sets of relations, okay, set of tuples. In the object-oriented databases, we have sets of objects, okay. In Java, when you are writing a program, you have a pool of objects, lots of objects are. Okay, so in the relational databases, the tuples are containing only primitive data, right? It means that when you define in the relational database, when you define a tuple or table, in each attribute of the tuple, it should be only primitive data. You cannot have a big object, you cannot have a big table as an attribute of the table. It cannot be nested inside. It's very simple. But in object-oriented, the object components can be also complex objects, like sets or complex types, like sets or set of objects, set of tuples, or also another objects. So the main difficulty here is that we want to expand or extend the capabilities from primitive to complex, so we need to change the whole structure. So for the object-oriented databases, we need to support inheritance hierarchy, which was not defined in tuples at all. Because in tuples we don't have any inheritance. We also need to add methods. Okay, here we have this query and we have this method on a movie. Okay, this method should be defined somewhere. In a relational database, you don't have that somewhere that defines this method. But here you have a class, this method is defined over there, and that class, when you call this method for this object, that the DBMS knows where he has to go and how he has to execute this. And in some of these systems, like for example, for some extension of Java, the ODMG, the object data manipulation languages defined by ODMG is exactly the same as the host language. In Java, when you define a persistent object, the object you have is exactly a Java object, but it's persistent. It means that there is a DBMS as part of Java virtual machine knows to save the object and it will retrieve it the next time you run the program. Okay, so this is the okay. So similar in the relational data model, what we did before starting defining queries and query languages, we defined a conceptual model, which was relational model, right? In the relational model, we had this relationship, and then we defined relational algebra on that, okay? Like join, like union, intersection, union, intersection of sets, lots of operations on that. Okay, here we need to define a conceptual object data model similar to relational data model in order to extend our data schema and extend our language. And similar to, okay, this conceptual model is shared and used common. It's common between all of the approaches. So it's very important to learn and to know how to work with this. For example, if you know this conceptual data model, conceptual object data model, and you can easily understand what is Hibernate doing, what is basically Corba doing, all of these techniques and approaches, even to understand how distributed objects models are working. And this is also similar to, it's very close to the models and the languages defined by ODMG. How many people are familiar with type calculus, the calculus and type calculus? Is there any course, advanced programming languages for you?
There's a programming languages course, but it's not really a type calculus.
They don't teach calculus over here, like
I don't recall
type inference and so on. So what do they teach over here? In advanced programming language?
Each of the programming languages in general, different types of programming languages, compilers and interpreters, workflows.
Oh, I see. Okay. The main, in compiler course, you learn that the first level of compiler work is tokenizer. Tokenizer is tokenizing the program. Okay. Then the second level of processing a program by the compiler or compiling is syntax analyzer. Syntactic analyzing, and at the same time, syntax analyzer is generating code for you. Okay. But one more interesting part of a compiler is semantic analyzer, right? Where the compiler, for example Java, is careful and it cares and it checks if your program is semantically meaningful. What does it mean? Semantically meaningful. It means that if in your program you put a string inside of a variable, you define it as an integer, it is not semantically correct. Okay, almost all of the semantically checking the correctness of a language, a program, is based on type calculus. So type calculus is a calculus or a theory, where you can define and basically where you define the calculus between objects and classes, and basically you define how these kinds of checking can be occurred in the compiler. So similar thing, but much simpler happens here, because in the type calculus, one more point, if you go and read type programming languages book by Pierce, you see that after chapter 4 or 5, it starts to talk about objects and so on. Objects and types, classes, objects, and all of this stuff. Subtyping relationships, how a type can be a subtype of another one, and so on, and all the constraints. And here we have similar stuff, but very simpler. So before going to conceptual object-data model, I just wanted you to be ready for similar concepts, but much simpler. In the conceptual data model, for every object you have to have an ID. Okay? Think about this ID as a pointer to the object, somewhere either on the disk or in the memory. So every object has a object has an ID, and this ID is different from primary key. So free your mind from primary key. Don't think about that relational model. This is just an ID for each object, and this ID is immutable. What does it mean?
Does not change.
It cannot be changed. So it means that when you create an object and the object is assigned with an ID, suppose that this ID is somewhere in some address in memory, then that address always points to that object. Okay? So it cannot change.
Does this mean that in object-oriented databases, objects don't have primary keys?
No, objects can have primary keys, but the object ID is something that required for the DBMS to handle all of those objects. So one more thing is in Java. Let's just jump to Java 1 for a second. In Java, also each object has an ID, right? Each object has an ID, and that ID is immutable, right? That is the difference for the object. Okay. Each instance, not each object. Each instance has an ID, but objects can point to same instances. Okay, instance means that when you create an object, when you call new operator, the object is created on the memory. Then that object is getting an ID. And from that point, Java virtual machine always pointing to that object. Okay? I want to write it on the computer, but I cannot write it. It's very difficult. Suppose that you have this class. And if in the body of a function somewhere you define what happens is when you call new, an object will be created, okay? Then this pointer will just reference to the object created, okay? Suppose that when I doing this, what happens? So
This point is
this Matthew is also again pointing to somewhere Bennett is pointing. So it points to the object ID that is created over here. If now here, if I create JIT as a new student, then a new ID will be created, a new space will be reserved, okay? Here, if I do this, Matthew is equal to JIT, then what happens is, this Matthew is now pointing to the object ID of JIT. If I do this, Bennett is equal to JIT, nothing will change on the ID that we created over here. From now on, Bennett is also pointing to the object, JIT is pointing, okay? If I do, for example, if I change the name of the and then now here, after that, I print out the name of the JIT, then result will be printed out. Why? Because this name of the variable is just a name, but the actual ID, the one that you cannot see, is the one created new and just assigned it to the variable. Similar to that concept here with the object-oriented databases, the main concept is object ID. And this is immutable, similar to Java. In Java, when you create an object, until the object exists in Java virtual machine, here, basically what happens is after this point, until this point, this ID is existing in a Java virtual machine, always keep it. But after this point, since Java virtual machine realizes that if you don't, nobody is pointing to this object ID, it can be removed by Java virtual machine garbage collector, right? Garbage collector will erase it. But similar to the same concept here, we have this object ID concept. So the key in the object-oriented databases. The key in the object-oriented databases is different from the object ID because key is defined in this level. Okay, you may define the key, the ID as a key. Okay, key is defined as an attribute. Okay, but object ID is the unique ID that is identifying the object, the whole object by itself. However, you can also, you still can define constraints and the keys. Okay, so objects are just the whole ID of the object. Is the pair of object ID and value. That's it. So very simple. So suppose that, just get back to the example that we have in the beginning of the class. Suppose that you have just this Joe Public's object, okay? So Joe Public, you remember that he has this social security number, this name, these are his phone numbers, and there are he had two children. One is this number and the other one is this number. His object ID is a number that you probably cannot see that, it's underlined. The rest is a value. The whole thing is a value. We'll talk about one value. But just think about this as a single value, but with different tuples. Okay, so the values can be either primitive or complex. Okay. So this value here can be either primitive or complex. So what is the primitive value? Integer. The string, also primitive value. Float is also Boolean. These are all primitive values, okay? So you can have one object which is in a string, okay? One object which is an integer. 23 can be an object. The value also can be reference value. It can reference to another object like this, okay? So you can have an object ID referencing just to another object ID. It can also be tuple values, like attribute 1, v1, value 1, attribute n, value vn. So when you have tuple values, you have a set of distinct attribute names and set of values assigned to each of that attributes. Okay, and also it can be set values. We talked about this at the beginning of the class. For example, a person can have a set of children, right? A person can have a set of phone number. Okay. So then complex values are the one they are reference, or they are tuple, or they are set. In opposition, you can have primitive values, which can be just only integer, string, float, or boolean. So this is an example. So what is the value of this object? What is the type of the value of this object? It's a tuple, right?
Phone number is a tuple.
So this is a tuple. This object is a type of tuple, right? It is a pair of pair of name values. Name, value. Name, value. Name, value. Okay? So let's consider one of these values. Social security number, this attribute, as a value, right? What kind of value it is? Primitive, right? It's just a single string, right? Name, what kind of value it has? Primitive. String. Phone number. Sets. Just sets.
Yeah.
Child.
Sets.
Okay. So can I have like for T a tuple A1, B1, A2, X1, and X2? Can I have something like this?
Yes.
Adding to this tuple? Yes.
Yeah.
What? This is the name of the attribute. This is the type of the attribute. What kind of attribute it is? Tuple. It also has pairs of. So then the whole thing for object number 32 is the value of object number 32 is a tuple consisting of these pairs of name values. Okay. Okay, now let's talk about classes. So, what are classes in object Java? No.
The collection of members,
So the
attributes, methods.
specification of a collection of objects, right? It is, you're specifying, when you're defining a class, you say that, okay, from now on, Mr. Java, just understand that the objects you are instantiating should have this form, okay? So they are basically a set of, they are defining a set of semantically similar objects, okay? Okay, so a class by itself has three components in the object-oriented, from the database point of view, from the object-oriented database point of view. It has three components. First component, type, okay? So what is a type? When you define an object and a class in Java, what is the type of the class? So suppose that I define a class student like this. So what's the type of this class? When I define the type, when I declare something in Java, I declare the class of this, right? The class of this, I define the class of the student. So this class is defining the type of this student. The type is the structure it has, right? So basically, the type of a class is a description of the common structure between all of the objects in the class, okay? So the common structure of all of the students are name and ID, right? String name, string ID. This is common structure. The second part of the data class, method signatures. We told that objects can have methods, right? For example, that what was the name of the method? GetFrame or something like that, right? In the slides before. Here, the frame range is a method, right? What is the signature of this method? Integer, right? So the class is also defining the signature. So the first part, type, the second part, signatures. The third part, for example, not only, when we are talking about Java object-oriented database, we can also think about Java Virtual Machine. Java Virtual Machine is an object-oriented database, right? It has a lot of objects, it manages all of those objects. We showed that in the same concept of object ID is existing over there, right? So here, Java Virtual Machine keeps for each class, keeps all of the pointers to all of the instances of that class, okay, for its own purposes. So that is called extent. So the extent is basically the set of all of the objects in that class. Okay. I'm using Java examples because I know that you are all very good at Java, so and it's a common concept, easier to understand. So suppose that you have this class student, okay, extending person. This is similar to the objects we had before, right? The student class the extending person, and it also has a student ID and also a set of majors, right? This is how you define the set in Java, right? Set of strings. Okay, so suppose that you have public class person, which is okay. So okay. Suppose that I instantiate two students. Okay, if I instantiate two students and one person, what is the extent of class students? What is the extent of class student? The object ID of this one is 32. The object ID of this is 51. This is created 59. Suppose that these object IDs are created. What is the extent of person?
It is a set with 32, 51, 59 in it.
Perfect. What is the extent of the student?
32 and 51.
Why?
Because of each person. A student is a person.
Yes, exactly. The student is a person. So when you instantiate the person, when you instantiate the student, the extent of this number also should be added to the person. Okay. So now you understand that if you have a multiple inheritance like C++, it's very difficult to implement something like this.
Yeah.
So C++ is doing a good job. Difficult job. Okay. Okay. So now let's start types and see what types are. So what are the types? What is the type?
Common elements between objects.
Right. The description, right? Description of common objects, commonality between objects, okay? So in the object-oriented databases, no matter we are using object-oriented databases or relational databases, when we are defining a type, the data should be properly structured. Okay, when you are defining the type of an attribute, basically, no, although you are in the relational databases, suppose that you are defining the type of attribute, relational. When you are defining the type, you are giving it a structure to that attribute, saying that that attribute will have integer, okay, will have a string, the format, the structure of the. Similar to that thing, this concept should be done in the object-oriented. When you are defining a type, you are giving it a structure. However, this structure is not as simple as what you had in relational. Why? Because in relational databases, for each attribute you have just private. But here, the structure of the objects are already different. Say you have sets, tuples, and each tuple can have pairs of attribute values, and also the attribute values can be also again a set or a reference or primitive or anything like that. So here, unlike relational database, you have complex types. So you have to be able to define complex types. So suppose consider this class, this object Joe public, okay, this person. What is the type of this person? If you want to describe the structure of that. What is the type of this person? If I give you another object, how can you distinguish these two objects are from the same class? If all of them have the same structure in their values, this is an object ID in this value, right? The value is very straightforward. You have a tuple, okay? The tuple, the first attribute of the tuple, the same name, a string, type of a string. Primitive type of string. Second name, primitive type, a string. Third name, set of strings. Okay? Fourth one, child, set of references. So if you name this type as a person, then the type of this will be like that. Okay. So based on that, you can give a formal definition for types. So basically, a type is one of the form. Either the type is basic. What does it mean by a basic? A primitive type, like float, integer, string. Or it can be a reference type. It can reference to another object, like user-defined types. Okay. Or it can be tuples, like this. Attribute 1, type 1. Attribute n, type n. Okay? Where the attributes are distinct attribute names, and types are also again types. So, and the set types, which is a set of a single type, that is T is a type, like a set of string, set of person. And for the complex type, we call references and type and set type complex types. So you understand this definition, right? It's a recursive definition, isn't it?
Same definition for the objects.
Right. But it is a recursive definition. You understand why this is a recursive definition?
Why do you say that?
Because to define type, I'm using the type until I end up with basic types. To check if something is type, I have to check if it's complying with that. If it is implying complying with this structure, okay? So how do you check the complying? It's complying using traversing this recursive definition for that. Okay, so that's where I was talking about subtyping and type languages. In the type languages, one very important concept is subtyping, okay? If a type is subtype of null, okay? What is subtyping? What is subtyping? Subtyping is that when you have a type
Belongs to the same class.
belongs to the same class,
Yeah. For
but
example,
maybe more specific, right?
yeah,
The student is a type of, it's subtype of,
person.
Person. it belongs to class of person, but more specific. It has majors in it. It
As
has
well as employees as also a
employees,
subtype of person.
subtype. So this is how we define relationship of subtyping, okay? But person is not, sorry, department is not a subtype of person, right?
It's a subtype of organization maybe.
Maybe. Yeah, I mean, if you have a boss, if you have a manager and so on, maybe you can define subtyping relationship. So here, so if you consider person and student, a person is a student. So a person has the same structure, some parts of it is as same as person, but it adds more stuff like room number, majors, course numbers, courses it has taken, right? So when you want to distinguish two types are forming a subtyping relationship between each other, or one type is subtype of another type, you need to just check the structure. If the structure is same, but the other one is adding something more stuff to that. This is called subtyping. What is the formal definition for the subtyping? What is the formal definition of subtyping? Okay. So I will give examples probably next week, like on Thursday, but let's go over that. Suppose that you have two types, T and T prime. Okay, T is the subtype of T prime if they are not equal. So, and if T and T prime are reference types, then T is a subclass of T prime. What does it mean? If they are reference types, this is a reference type, right? This is a reference type. Is 51 subtype of this one?
No,
No, why?
because they're the same.
The same, right? Is 59 subtype of 32?
Yes.
No.
Because they're
No, this one. Is 32 subtype of 59?
yes.
Yes, because it is the type of, the class of 32 is student, it's a subclass of the type of 59, which is person. Okay, so when T and T prime are reference types, then you have to consider these classes. When T and T primes are tuples, how do you distinguish that they are subtypes? If you have T as A1 to Tm, and T prime is A1 to Tn. And note that n is less than m, okay? They are subtype if and only if for the common part, names are same and values are subtype of each other. Subtype of each other, right? Yeah, well, I need to give examples next. And subtypes of sets. Suppose that T is a type of T0, set of T0s, and T prime is type of T prime zeros. T0 primes. So these are T is subtype of T prime if and only if T0 is subtype of T prime, right? If you have a set of a student, that set of a student is a subtype of a set of person, right? So this is the definition between for subtyping. I will give more examples on tuple types next Thursday. Any questions?
No.
No? Okay, good. Quiz of distance learning students. The quiz because of some reasons, some security reasons, the quiz is a little bit different than what you had last week. So here, as an example, I'll try to solve this quiz. Consider the Adventure Works 2016 and answer the following questions. First question. Consider the following query. Okay, it's pretty much long query. And so I need to make it smaller to fit. So, do you see that, this query? Now? Look at what now? You can't see that, right? So, what is the query? What does it say? It is selecting the business entity ID from some tables. Okay? Making a table in union with another select. Okay? What is asked in the first query? Start date is, their start date is equal to all the people, all the employees, okay, that they got a new department on the first day of January 1999. This is the basis. What is the second query? All the people who got change on their salaries on the first day of January 1999. Okay? So these are two queries. So suppose that these abbreviations are given to you. So let me make it bigger because these are relational. Which of the following relational algebra is not equivalent to that query? Any guess? Is it difficult? Suppose that X is the January 1st, right? January 1st of 1999. Okay? EDH is the starting date of employee department history, and SD is starting date. Okay? EPH is employee payment history, and SD is starting date of that history or that date. Okay? So let's talk about the first option. Is the first option equivalent to that query or not? We are doing a join on person business entity ID, then EDH business entity ID, okay, then employee business entity ID, and then we put this EDH, this constraint on that, union with employee business entity ID is equal to business entity SD. We select a start date of the EPH multiplied to employee, and then the rest is we're putting this constraint that employee with business entity ID is equivalent to. The first one is not the answer. Why? The first one is not the answer. Why? Because it's equivalent, right? What am I doing here? I am basic thing. Here, this is the first join, right? So this is the first join. I'm putting this constraint of checking the start date of the department history. This is the second join. Instead of join, I put Cartesian product. Before the Cartesian product, I filter records from the employee payment history based on the date, the start date, okay? Cartesian product, and the Cartesian product, I put this constraint, is equal to join. So this is also same. So this is not the answer. We are looking for not equivalent, yes. So what is the second one? Second one is similar to the first one, because we are multiplying employee into employee payment history, putting this constraint to make it join, putting this constraint to filter the desired records. The rest is okay. Third one. No joins here. Is that correct? Yes, it is. Because in order to retrieve the business entity ID of the employee department history, you don't need anything from the table's person or employees. This is the trick of the query, right? So this is correct. What is the rest of it? This part is correct. EBID. The rest is also correct. You're doing a join, selecting the desired records, and then the item. What is the fourth one? This is also correct, right? Obvious. Fifth one. Fifth one is also correct, similar to this one, right? Instead of EDH, I'm using EPH. In EPH, employee payment history, you don't need the business entity IDs are there, so you don't need other tables. So, what about the last one? There's a point over here. So what's wrong with the last one? Any answer? Oops. You need to find the problem.
Can you make it bigger, please?
No, hold on. Why is it? Text is getting bigger, but it's probably not.
Because the windows are on that before.
Yeah. Why is it? I don't know how to make it bigger. Do you see it? Problem?
Can't read the query,
Oh, you want to read the query?
or the algebra, I can't
Oh.
read it, it's too small.
Oh. Okay, I will put it as a discussion.
Okay.
Okay.
That will be nice because it's very hard to see that.
Yeah, and it looks like we're in a rush and